way, when I was a child,
when you were young,
and there were dinosaurs on the earth and all that, there weren't
calculators.
Well, calculators that could do logarithms were just starting to come out, and they were very expensive. So most kids didn't have them, and most kids had a table in the back of their Algebra 2 book, which told them the most commonly used logarithms. So what we would do is you do something like this. You take the log base 5 of both sides, okay? Now, this is an exponent. Based on this rule over here I just gave you, I can take that exponent and I can bring it down to here. Okay? And I now have, instead of log base 5 of 5 to the x, I now have x times log base 5 of 5. Here's why I chose this one. What is the log base 5 of 5?
1.
1. You got to get used to this. That should have been everyone in unison quickly. Log base 5 of 5 is the question. 5 to the what power equals 5?
1.
1. So log base anything of the same number is always going to be 1. All right, so this is 1 times x. So I now know x equals the log base 5 of 125. If I don't have a calculator, that might not be hugely helpful. Okay? So let's say I do have a calculator, and I'm at this step here. 5 to the x equals 125.
So you just crossed out the log and the big 5?
Log base 5 of 5 equals 1. So this is x times 1
okay.
equals log base 5 of 25. And if I don't have a calculator or my chart, and I don't know that 5 cubed is 125, I'm pretty much done here. Actually, and this is the final form of my answer. So all I've really done is rearranged this in those steps. If I have my calculator, I have to use one of two types of logarithms. What are they? Base E and base 10. Very good, Saul. So if I have a calculator, I'm going to use one of those. Pick one, Saul. 10. Okay. I will take the log base. I'll take the log base 10 of 5 to the x, and I will say that's equal to the log base 10 of 125. All right. I will then use the property over there to take anything in the exponent category, and I will mess up writing it. So I just bring the x down from exponent to coefficient. I call that whooshing. I will whoosh the x down from the exponent to the coefficient spot. I don't know why I started calling it that. I just do.
Have you always called it that?
Yes.
Has it just been, or was it just today?
No, I've always called it that.
Oh.
Even as a child. I don't know where it came from. None of my teachers called it that. So I'll whoosh this thing down to the front.
Did anyone else? Did anybody think it was funny?
No.
Okay.
So now this is the log base 10 of 5. I don't know what it is, but it's some number. Okay? There's no difference between, this is x times a number. When x is multiplied by a number, what do you do to get x by itself?
Divide it.
Divide it. If this were 5x, you divide both sides by 5. If it were a million x, you divide both sides by a million. So x, after I divide both sides, is going to be log base 10 125 over log base 10 of 5. And I'll bet you money that when you put that in your calculator, you'll get 3. Because I know that 5 cubed is 125, as everyone else did. If I didn't know that, this is the process I would use. Well, it gets faster at it. Incidentally, if this looks new and strange, we know that this is the same thing as log base 3 of 125 is the way to rewrite this statement. Log base 5 of 125 equals 3. What we've just done here, you don't have to get this, but it might be helpful. We've just actually proved the change of base rule. Because log base 5 of 125 can be rewritten as log base 10 125 over log base 10 of 5. So this is actually where the change of base rule comes from.
Okay.
I actually don't like that your textbook teaches change of base first before this.
You should write your own textbook.
I should write my own textbook.
Wait, so aren't you just going to do division the entire time? Just have a log on the number?
Well, yeah, but this is the vital step. You got to take the x from the exponent spot and bring it down to here.
I know I'm just saying this because, like, I know the answer and everything, and, like, I know 5, 125,
Right.
root. I mean, like, couldn't you just figure it out on your own? Be like, oh, 125, 5, you need an exponent that goes into it. It's definitely going to be something that goes into it.
Yep.
Same times you multiply 5 equals it. You just do that all the time.
On this problem, that'll work. Let me me give you another one and let you see what you think the answer is. Okay? 5 to the x equals 125. Hope you have your calculator handy, because now I'm going to say 5 to the x equals 127.
3.1.
You know, that's probably a good guess, and it'll probably be close.
3.14159.
If it turns out to be pi, I'll be really startled, actually. But it could, for all I really know. Okay, here's the process you follow. You pick one of the ones on your calculator, log base 10 or natural log. Log base 10. Everyone seems to like that.
Yeah. It's going to be something with 9.
All right, log base 10 of 5 to the x equals log base 10 of 127. Okay? I whoosh down the x. Okay? This is just x times a number. So I divide both sides by that number. And x will equal whatever the log base 10 of 127 divided by the log base 10 of 5 is. I have no idea what this number is. Saul, I'm guessing you're close. What do you get?
I don't have one of my calculators.
Okay, log base, on your calculator, you'll hit log. It'll give you an open parentheses, right? 127. You'll close the parentheses before you hit the division sign.
And then log 5.
And then log 5. I honestly don't know if it matters if you close that parentheses or not, but I do out of habit. 3.0098.
Yes.
I'm going to leave it there.
I totally have
Actually, that's far enough.
Yeah.
Kind of close. 3.01. Actually. Okay? So these are the steps you follow to solve it. Now, the other way these rules are used is with some just algebraic rearranging to prove you understand these rules. Okay? So they're just some expanding and condensing exercises. I'll show you those, what they look like real quick.
Also, I'd round that to 3.00.
You're just mad.
I realize your mutterings are going to be online.
That's fine.
All right.
Me
Okay.
owning James will be documented.
You did not own me. You
Oh, I
said
did.
3.9. It is 3.00.
I said 3.